Hi students, welcome to yet another episode of High School Physics with Haldar sir. Today's topic is Newton's law of cooling. So let's get going. Newton's law of cooling states that the rate at which a hot body loses heat is directly proportional to the difference between the temperature of the hot body and its surroundings. Mathematically speaking, minus dq by dt is proportional to T minus T naught, where T is the instantaneous temperature of the hot body and T naught is the temperature of the surroundings. So, shifting the negative sign to the right hand side and replacing the proportionality sign with a proportionality constant k, we can write d cubed by dt is equal to minus k into T minus T naught. Q can be written as the product of mass, specific heat and temperature. So d by dt of mct is equal to minus k into T minus T naught. The product mc being constant, we write it as and then take the product mc below k on the right hand side. We now write the constant k divided by mc as a new constant capital K and designate this equation as equation number 1. We now integrate both sides of this equation, the left hand side being integrated from t initial to t final and the right hand side being integrated from time t equal to 0 to t. On integrating, we get log natural of t minus t naught evaluated between the limits t initial and t final is equal to minus kt. Further, we write log natural t final minus t naught minus log natural t initial minus t naught is equal to minus kt. which is the same thing as log natural of T final minus T naught divided by T initial minus T naught equal to minus KT. Writing this equation in terms of log to the base 10, we have 2.303 into log to the base 10 of T final minus T naught divided by T initial minus T naught equal to KT. This is our final equation, and we designate it as equation number 2. I will now go ahead and show you how we use this knowledge to predict the temperature of a hot body at any given time. For this, we take the following example. A hot cup of coffee cools from 80 degrees C to 70 degrees C in 5 minutes. How long will it take to cool from 70 degrees C to 60 degrees C? The room temperature is 20 degrees C. We will solve this question by two different methods. The first method is the rigorous method. Here we use the equation number 2 which has been derived above, and we just plug in the values of the final temperature, the initial temperature, and the room temperature, which is the temperature of the surroundings. We cancel the zeros from the numerator and the denominator. And designate this equation as equation number 3. Now, we plug in the values of the final and the initial temperature of the second time interval which has been asked. Again we cancel the zeros from the numerator and the denominator. This t is the unknown time. We designate this equation as equation number 4. Now, dividing the equation number 3 by the equation number 4, we get looking up the log tables for evaluating the numerator and the denominator. We write 0.8171 is equal to 5 divided by the unknown time, which gives us the value of the unknown time as 6.12 minutes. The alternative method is a relatively easy one. Here we use the equation 1 derived above, but with an approximation. That is, in place of the instantaneous temperature T, we write the average temperature during the time interval. So now our equation number 1 looks like dt by dt is equal to minus k times T average minus T naught. Now putting the values, we get 10 by 5 equals minus k into 75 minus 20, and that makes 2 equal to 55 minus 55k. We call this equation number 5. Also, from the second condition, 10 divided by dt is equal to minus k times 65 minus 20, that is 10 divided by dt is equal to minus 45k. and we call this equation as equation number 6. Now simply we divide equation number 5 by equation number 6 and we get dt by 5 equals 55 by 45, which is the same as 11 by 9, which yields the time interval dt as 55 by 9, that is 6.11 minutes. If you compare the results of the two methods for solving the same question, you will see that the alternative method differs from the previous one by 0.01 minutes, which is absolutely negligible. If you found the video useful, then don't forget to click the thumbs up button and the subscribe button below your screen.